Welcome to Face Forward, the podcast, the series that takes you behind the scenes of the riveting world of clinical trial management. I am your host, Valerie Coveney, and I am thrilled to be your guide on this journey through the nuances of planning, executing, and navigating the clinical research landscape.
In this episode, we will be tackling some of the most common mistakes in RTSM, sharing proactive steps to avoid these pitfalls, and exploring real-life case studies with practical solutions. Joining our roundtable today is Kelly O'Brien, RTSM Senior Project Manager at Veeva, Andrew Rohrbaugh, VP Strategy at Veeva RTSM, Éric Hardy, Senior Director of Biometrics at Innovaderm, and finally, Oliver Hewer, Project Manager at Innovaderm. Thank you all for being here today.
Thanks, Valerie. Happy to be here.
A pleasure. Thank you, Valerie.
So in your combined experience, what are some of the most common mistakes seen during the setup of RTSM systems? Kelly?
Yeah, I think that one of the mistakes that we see is oftentimes not planning enough conversation around user acceptance testing. So that would include who is participating in UAT. Will that be our sponsor team? Will that be the clinical team, biostats, so that we understand what to frame within our test cases that we write for our user acceptance testing. So knowing who is planning to run user acceptance testing, making the test script as comprehensive as possible. So not just including a happy path through the system, which would just be testing what we know and expect to work, but also including negative checks. So that could be important around calculations, stratification, anything that is critical to the build of the RTSM system.
And I think building on that, another piece is really just being proactive. UAT is something that we want to plan early in partnership with sponsors and CROs in terms of, again, as Kelly said, the resources involved, the timing of it. You never want to come down to the wire ready to release to UAT and only plan at that time. It invariably causes delays or challenges.
Yes, I agree with the team. It's really important to allocate enough time to the UAT, both on the vendor side and on the CRO side. UAT takes a lot of documentation, but it's not just around the UAT. We need to have very clear documents also, because all the UATs, the testing will be done against the documents. So it's really important that both parties are very clear on the expectation and all of the needs and the requirements.
Yeah, and I agree with what everyone said so far. Having a really clear set of specs up front and having a lot of discussion about those specs and making sure you're getting it as right as possible from the offset is really critical. And then, as Kelly mentioned at first, making sure that you are performing the tests according to all of the roles that you need, all of the situations you need that you're expecting to come across in the trial, are really important to do that as part of UAT testing, so that you don't kind of come across these problems as the trial is up and running. And these are things that, I'm sure we've all experienced on running a trial, is that you might have missed something. Some things do slip through the net, but getting the specs right and then performing the testing according to all of the possible situations that you've got is really key.
Could we go over some examples of missteps?
I think two of the top ones that come to mind are really trying to use RTSM for more than it's really intended. At its core, it's randomization, it's trial supply management. The kind of golden rule around it was sites will never use the system unless they have a carrot to do so. So if they need to enroll a patient, randomize a patient, get a kit number, they will. But if we suddenly start adding additional data points to capture, or things that typically would go in an EDC system, it adds burden to sites. They can get very frustrated. We've always heard that sites are so focused on the patient and everything else that they have to do at a given visit, that being able to get into the system and get out of it quickly is really their ultimate focus.
And I would say I was also speaking about clarity of all the specifications. If we only realize later in the process that something was not clearly defined, it's possible that we will test the wrong thing, or we would get unexpected behavior from the system. So it's important to do this. And I think that also, because I was talking about the timelines, sometimes trying to go too fast could also create errors. Everybody's going fast. It's possible that somebody will miss something. And of course, it will create more rework down the line, pushing timelines. So those are the important things in my mind.
And I think it's not just UAT, but even in the system build itself,
right?
I had a mentor that used to say, just because you can build a system in 2 weeks, should you? Because you never want to sacrifice quality for speed, whether during the build from the vendor side or during the user acceptance testing.
Can't agree more.
Okay, so how can teams proactively address these issues?
So when speaking of the programming and especially important, the schema of the randomization list and requirements, we want our biostatistician team to have sufficient evidence that one, we're using the appropriate randomization scheme, two, that our randomization list that we have loaded in both our UAT and our production environment are as expected. So one of the things we can do to help plan for that is to build a specific role in our RTSM that allows the unblinded statistician to go into the system during UAT and once we're live and in production and review those lists, make sure that they are as expected. They match 100% to the list that was provided. And then we mentioned user acceptance testing. So we also give our team, the BIOS team, their own unique scripts during UAT that follow more the randomization scheme and less just the clinical flow. So it gives them more of an in-depth view of the randomization build directly.
Yeah, I agree with Kelly. It's important that the biostat scheme can test everything that is related to randomization. We will often test that every stratification has been covered to make sure that the randomization will be performed correctly during the course of the study.
Excellent. So on to some proactive steps. Éric, what would you recommend on some steps our teams could take?
So something we touched on briefly previously is talking about preparation. So having a good kickoff meeting so everybody's online, everybody has a good understanding of the protocol, the requirements for the RTSM. And what's been working great for us is also when we have repeated business like that, so we can build standard. And instead of having some very large document, not easy to understand, having some very specific documents of our relationship and simply modifying what needs to be adapted to be specific to the study, it makes it easier for everybody to understand them and be on an agreement with them.
I was just going to say to your point, Éric, during the kickoff meeting, we have the first opportunity to meet everyone that's involved in the trial. And I think a good conversation to start with all of our stakeholders is understanding what each individual role will be in RTSM. So we have a clinical team, we have an inventory management team, we have a BIOS team, our sponsor team. So addressing and making sure that we're building the system for each of those user roles so that if a clinical project manager needs access to turn on or off cohorts or manage caps, we build that into the system so they have that direct ability to make those changes. So we continue that discussion in defining all of our permissions for users. So we want to make sure that our system is robust, that each person who has a role in our system, we build for them specifically and for that role. And that also includes blinding and unblinding access.
I would add, I think another piece around being proactive is not just building the system to meet the needs of the protocol, but thinking critically about what may happen in reality, because your protocol is always your hypothesis. You plan for how you think it will work, but reality often changes. So if you've got a lower age limit, but not necessarily an upper age limit, and the system isn't blocking or controlling anything, is there actually an age that you do want to control or that you want to limit to, or dose levels or weights or things like that? So not just looking at the assumed boundaries, but building it enough that you don't end up with a patient waiting at site where they can't get a transaction to complete because the RTSM was built too restrictive under the assumption rather than what may potentially occur.
Yeah, and just going back to what Kelly said there about identifying the roles of who is going to be using the system early on, I think this can build into UAT testing as well. And one thing that's worked quite well with us, I know in the past, is if it is at all possible, if you're able to identify people from those areas to help with UAT and to conduct UAT. So, for example, you've got a blinded statistician who is able to UAT with the role of a blinded statistician, or a CRA who is, available to help UAT test that particular role. That really gives it some real life kind of expertise when you're kind of looking at what this role needs to do, what the parameters of this role are, and it really kind of helps set the system up where possible in as kind of accurate a way as possible.
Haven't seen it much, but taking that thought a step forward, I've seen a few sponsors that actually have sites participate in UAT as well, where maybe it's key opinion leaders for a given therapeutic area or study, but their feedback is often very beneficial in terms of site workflow versus system workflow and ensuring it's as smooth as possible.
And previously, Andrew, you were talking about the build and try to think about the possibilities, of course, based on the protocol. What about integrations? Do you try to think ahead about integrations with like EDC system or any other system?
Yeah, I think it's another key area for sure. Anything that's adjacent to the system or in any way impacts the system. If you were to build some sort of integration that would control dosing or eligibility or something along those lines, technology is great until it doesn't work. And if there's a transmission failure, if there's a file failure, if there's some sort of value that just won't go through, having the right error handling in place or the right backup methods so that you can quickly and easily pivot again to ensure that sites and patients aren't interrupted and impacted.
Let's move on here to the importance of thorough planning and clear communication. Kelly, what could you share with us about these points?
So what I recommend with study development is, we start with our kickoff meeting. We understand who is on the team, what their roles will be. We define our stakeholders. So then we carry that communication forward, and we want to schedule weekly or biweekly meetings so that we can continue communication around the protocol, our RTSM requirements, making sure we address any questions that the team may have, making sure that the team understands what we're building for them. And what helps in these meetings is that we can also share our system build as part of our design reviews. So having that time to communicate with your team, to address questions, to show them the progress that we're making during the build process really lends itself to a successful build, so that by the time we get to user acceptance testing, the team has a good understanding of what we've done in RTSM and what they can expect from their system.
Yeah, Kelly is spot on. I think if we distill it down, really a key aspect of it is just making the best use of everyone's time. Study startup is such a burdensome time for both sponsors as well as CROs, and ensuring that when we are meeting, we're making the best use of people's times. We're moving the ball forward. We're progressing and answering questions and allowing focus, and then allowing everyone to go on to the next system, because it's just one of the many systems that everyone is trying to get up and running all at the same time and in parallel. I think another key piece of the communication is also just around requirements themselves, because in any eClinical system, you're taking your protocol and you then have to translate that into system-specific requirements. And you want to ensure that those are always clear, because what happens is the protocol becomes a requirement, then goes to an engineer, then goes to a tester. And if anything is even slightly ambiguous, can be open to interpretation, your end result may be a bit of whisper down the lane and end up very different than you had intended.
Excellent. So let's go on to best practices for system validation, user training, and continuous monitoring. Oliver, could you give us a bit of information on that?
Touching upon what Andrew just said there, you spend a lot of time setting up these systems. It's quite burdensome. You have protocol-specific requirements, and you also have system-specific requirements too. One of the elements of best practice, I think, is in terms of user training and continuous monitoring. You can make sure that you're not just relying on off-the-shelf training and instruction materials. You might have manuals for these systems that you've set up already that have got kind of standard instructions and things like that. But you've done a lot of testing. You put a lot of work into setting up these systems, looking at it from all possible angles. You've got protocol-specific requirements and you've got system-specific requirements. Include those in your training materials. Include them in your manuals. You've learned a lot from that process, and those are really important things that you need to kind of then impart on the actual users and instruct to the actual users of these systems as you're running the trial.
And to add again, related to timelines, it's very important to give enough time for the UET. In the CRO world, documentation is everything. So we need to have a thorough documentation of everything that is tested. So it's important because all of this takes time.
Definitely. And on here to some tools and techniques for ensuring data integrity and system reliability. Kelly and Andrew, do you think you could shine some light on this?
Sure. Yeah, I had mentioned the role of the unblinded biostat. So I think that's a great way to ensure your data integrity with your randomization and your kit list. So that's the backbone of the RTSM build in many ways. So having the ability to go in and review those very important lists as part of the system review is key, I think, for quality and data integrity.
Yeah, and I would say in terms of both RTSM vendor system validation as well as user acceptance testing, a key aspect of it is making sure you're doing the appropriate testing, especially if you have something that's more complex or unique. We've certainly seen in the past what we would call a happy path, where you just go through, the transaction works perfectly every time, very simple to get a patient through because everyone wants to get it done quickly, as Éric said earlier. But making sure that you do that boundary testing, you're testing upper or lower limits or dosing tables if the doses can change and increase and decrease throughout. Not necessarily every single piece of it during UAT, but enough to feel confident that everything has been built and tested appropriately.
Excellent. Okay, so on to our last point for today's episode. Could you guys share some real-life case studies you would like to share with our listeners?
I'm going to go big. I had several small examples, but I'll go big. There was in the news, there was a company that reported they had several phase 3 studies in progress. They had completed, and upon reviewing the studies, there were errors with the randomization lists. And what it meant was the data for multiple phase 3 studies was essentially invalid. They found out after the fact, when they went back through, that the drug actually was helpful, it was beneficial, it did outperform the comparator, but because of the data, they couldn't utilize it. They ultimately ended up having to shelve the compound due to cost implications and ended up laying off about 50% of their workforce. So as a company, they've now laid off half their workforce. A drug that did actually work will never see the light of day, or at least not for an extended period of time. So even if you think of the patients that are impacted by that disease. So back to everything that we spoke about, it was missed during the creation of the randomization lists, the verification of them, the testing within the vendor, the testing in the UAT as well. And holistically, it meant a huge monetary impact, but also a huge patient impact.
I think it's very important. I've been in that situation before where, you think that, you have a randomization list, you work with one kind of list, and then the vendor worked with another kind of list. Just sometimes adding one more column to a list can mess everything. And you often don't think about that kind of thing, but you only realize it at the end of the study, as Andrew was saying. It's devastating for a company.
It's interesting too, because there is a bit of human psychology in terms of the testing. When you look at a document that requires a signature, there's been studies that have proven the less signatures are on it, the more thoroughly someone reviews it. If there's 4 signatures, everyone assumes the other 3 are reviewing it. And it's somewhat the same when it comes to the RTSM and testing. By the time you get to UAT, yes, your vendor should be doing their sufficient validation, but you still need to make sure it meets the needs of the protocol. Everything is done appropriately, and that's really the purpose of that testing.
And because I think that the randomization is so important, I mean, it's not the only usage of or the only function for the RTSM, but it's really important to a study. I think what you were saying, Kelly, is to have a biostatistician looking at an unblinded biostatistician, obviously looking at the data from time to time to make sure that the schema is respected. I think it will simply help to make sure that the study goes well.
Yeah, I agree completely. That's been something I'm passionate about. I also really appreciate that we have randomization specs that outline the requirements, and it's only the randomization biostatistician and the unblinded team who actually review and sign off on those. So we are responsible for the importance of the details in that list, the number of digits, how each stratification will be, allotted. So that randomization spec really sets the stage for quality and having something to use as a reference for validation or testing.
Yeah, we've talked a lot about being proactive, but Éric, I think what you just mentioned about having an unblinded statistician being able to check the study at different milestones and time points, RTSM is a technology, it's a software. As much as everyone plans, issues do arise, and the earlier you can identify those, the more quickly you can pivot, address them, and minimize the impact.
This concludes our episodes for today. It was a true pleasure having you on the podcast. Thank you for being here.
Yeah, and thank you. It's so nice to be part of a podcast with like minds where we think and speak the same language.
Yeah, I agree. Great conversation. Thank you, everyone.
Yes, thank you. Thank you all.
Thanks very much, everyone.
As we conclude another illuminating episode of Face Forward, we find ourselves at the crossroads of science and progress. Remember that behind the jargon and statistics lie stories of unwavering commitment, meticulous observation, and the pursuit of evidence that shapes our understanding of health and disease. Stay at the forefront of knowledge and innovation and follow Face Forward on your preferred platform. My name is Valerie Kovney. Thank you for joining us. Until next time.